One of the most powerful things about computers is their speed, meaning they can perform tasks just at superhuman rates, which comes into handy because sometimes there's a lot of things that you need to get done. Let's imagine that you're trying to write a program that repeats a series of commands over and over again. This is a situation that you can reduce to something simpler if you use what we would call a loop. A loop is a structure within code that uses a Boolean test to determine whether it should continue to repeat a line or lines of code. You can sort of think of it like an if statement, except it's constantly reevaluating that Boolean test. So you come in, you check if the test is true, and if it is, you run the content within the loop, and then it comes back to the test. Is it still true? Continue to go until that test is false, and then you can move on to the code after the loop. This is going to save you so many lines of code. One of the loops that you might find useful is what we would call a while loop. It runs while something is true. So you start with the word while, and then you put your Boolean test in parentheses, and then whatever you want to repeat inside the while loop. This is really useful if you want to continue to repeat something until an event happens. Now, it's really easy to forget when to stop your loop. So you're probably going to want to start with some sort of variable that lives outside of the loop. This is so that the variable scope extends beyond a single iteration of the loop, because within a loop, the scope resets every time it repeats or iterates. So in this case, we have a variable that starts just above the while loop. Then we have a test that's like, hey, as long as the person wants to keep playing. Then inside of the loop, we play our game, maybe we run some pieces of code, and then we reevaluate the variable. We want to give the user a chance to say eventually, no, I want to stop playing. So whenever you're writing a while loop, make sure that you have some sort of variable and that you're updating that variable inside your loop. If you don't update and it never evaluates to false, then you're going to get what we would call an infinite loop. And you'll get some weird errors where you might get like Stack Overflow because your computer eventually just runs and runs and runs until it runs out of memory and crashes your program. Another incredibly common type of loop is the for loop. The for loop is similar to the while loop in that it runs based on a Boolean test, but it manages your variable for you. So it has a more deterministic set of runs. It's not really waiting for an event. You're sort of initializing it with exactly how many times you want it to run. The for loop has a header that has three distinct pieces to it: an initialization of the variable, a test on the variable, and then an update. You had those three pieces in the while loop, you just sort of had to do them yourself. For the for loop, they're all contained within the header, just like we have here. You'll very regularly see the variable named I used as the for loop variable. It essentially stands for iteration. For loops follow a pretty complex pattern, but they do it so fast that it's very seamless. First, they initialize the variable to whatever number you indicate. Then they check the test. Hey, based on this variable, does my test evaluate to true? If it does, then it goes and runs the code within your loop, and then it comes back to update your variable however you've chosen to update it. Here we're using the ++ sign, which is just shortcut for adding 1 to a number. You'll probably see that most commonly used in for loops, but you can actually change the pattern of your variable with whatever arithmetic operation you want to use. Let's take a deep dive in how the for loop executes. So, first things first, we define our for loop variable. We set it to whatever the initial value is. Then we're going to check the test. Hey, based on this value of I, is the test true? In our case, it is. So it goes through and it runs the line of code, which produces a line of output. Then it updates I. So I is now a new value. And it comes back around and it checks if the test is true. The test is still true. So it runs the line of code, updates, checks, so on and so forth, until eventually I runs off the end and our test evaluates to false. At that point, it's going to run the line after the for loop. Sometimes one loop just isn't enough. You can get some pretty complicated programs. So let's say we have a line of code that's repeated within a for loop. Meaning, in this case, it's going to run an exponential number of times. Well, we could replace this with another for loop inside of the loop. So it's going to run whatever is inside the loop some number of times, and then it's going to run inside that loop more times. This gives you really powerful lines of code. A nested loop is simply where you place one loop inside of another, giving you an exponential number of runs. So in this case, you can see where you have an outer for loop that runs some number of times and an inner for loop that runs another number of times. Meaning every time the outer loop runs, that inner loop is just running and running and running. So you get a really complicated output like we see here. This is often used when you're sort of thinking in a two-dimensional way, maybe like a grid. Now, you can use the outer for loop variable within the inner for loop, meaning you can change how many times the inner for loop runs based on which iteration of the outer for loop you're on. So if we use I as part of the test, or say the initialization for the inner for loop, then we can make sure that inner for loop is running a different number of times on each iteration of the outer for loop. In this case, we get ourselves a nice little triangle, meaning the inner for loop ran once the first row and then twice the second row and so on and so forth. When you're doing this, it can get a little sticky because there's so many things going on. So one of the most common mistakes is mixing up your loop variables. So a lot of times you'll see the I used to both initialize both loops, then you're going to get a big error. Or if you forget to update which one you're using when, you can sort of get this infinite run. Loops are going to make your program so much more powerful because they're going to be able to just run so many tasks very quickly, meaning it's going to save you lines of code and it's going to help you find patterns and then use this structure to leverage the computer's abilities. Loops make sure that you're getting lots of things done and very quickly, but it's really important to figure out the pattern of what you're doing. Loops just repeat whatever you've asked it to do. So if you can distill your work down to a recognizable pattern, and then you can abstract out those changes, you can write a loop that does a lot of work very quickly and still solves all of your problems.